All right, moving on to question 7. So it is ideal that we pause the video, read the question, and then write it out. So now I hope we've done that. So obviously A is a solution of A is 10.1 gram per dm cube, solution of a diabetic acid. So in a sense, A is standard, but there's no how we can get the molar conc of the diabetic acid, simply because we don't know the molar mass of H2S of the diabetic acid. But B in its sense, B is a solution containing 0.500 mole of NaOH in 500 cm cube solution. Now, this one is easy for me to get the concentration, either in mole per dm cube or even in gram per dm cube. Now, let's look at what we do have here. Find the conc of B in mole per dm cube, conc of A in mole per dm cube, molar mass of the acid, relative atomic mass of S, and the percentage by mass of X in H2X. Now, looking at this, it's easy for us to get the solution, because when we look at B contains 0.0500 mole in 500 cm cube. So it's easy for us to know what will be in 1000 cm cube. Let's proceed. Let's go to the page. So conc of B in mole per dm cube, how do we get it? We look at the relationship. We have that 0.0500 mole of NaOH is found in 500 cm cube. Then what mole, X mole of NaOH we have in 1000 cm cube? So my X will be, first multiply 0.05 times 1000 is equals to 500 times X. If you make X at the formula, you get 0.0500 times 1000 divided by 500. So our X will give us 0.100 mole. So that statement simply means that the conc of B in mole per dm cube will be what? 0.100 mole per dm cube. Now, the conc of A in mole per dm cube, like I said earlier, it is not easy for us to get conc of A in mole per dm cube, even though we have its mass conc, because we cannot derive right now the molar mass of H2X. X is an unknown. So because we cannot do that, that's why we will use our neutralization factor, which is CAVA. So we'll proceed by using CAVA over CBVB is equal to NA over NB. I've always said it's paramount, very important that you write the mole ratio. So NA is 1, NB is what? 2. So VA, I'm using my own VA as 12.20 cm cube. You can use your V as any tighter value that you derive on your own. So VB is 25.00 centimeter cube. So working through this, if I make CA the subject of my formula, my CA will be equal to CBVBNA over VANB. So after doing all my substitution, I will get 0.100 times 25.00 multiplied by 1 divided by 12.20 times 2. So in the end, I will get my CA to be 0.102 mole per dm cube. Now, there is a slight mistake on this part here. Now, that slight mistake is this. I want you to look at it like this. Sorry, there's no slight mistake actually. So let's proceed. We know that molar concentration is equals to mass concentration divided by molar mass, isn't it? So in this sense, the mistake is not very big. What we can write it as is that we can write it as mass conc over molar concentration. That was a mistake. So the mistake is like molar mass instead of mass concentration. So this one, you see mass conc over molar concentration. That is 10.1 divided by 0.102. That will give us the molar mass. So our molar mass here is 99.0 gram per mole. So obviously, if you add all the relative atomic mass, it always gives us the molar mass. So how do we get X? This is how we get X. The next slide says H2X, 2 times 1, H is always 1, plus X is equal to 99.0. So 2 plus S is equal to 99.0. That means my S is what? 99.0 minus 2. So my S is what? 97.0. The percentage by mass of X, the percentage by mass of X is obviously going to be mass of S over mass of the whole thing together. That's 97.0 over 99.0. So that will be 98.0%. So that's it. The only error I see in this calculation is that instead of me to write molar mass of molar conc of H2L, I'm going to write molar mass of H2L. And that I. The formula should be, I repeat, molar mass of H2O should be equal to mass concentration over molar concentration. That's the correct thing to write there. Thank you very much. Let's go to the next question.